now of calculating improper integrals. And I may have told you the wrong number, but I think I said I can't remember what they are, so I will now tell you in case you suddenly have to know which type we're talking about. If you're doing an improper integral where one or both of the limits of integration is infinity, these are called type 2. If you're doing an integral where the problem is a vertical asymptote, in this case at 4, they're called type 1. Right? So that's the two basic types of improper integral. We're going to focus today on type 2. So I'm going to just mute everybody because I'm getting some feedback here. And we got this guy. So our quest, if you like, is to try and find as many different situations of improper integrals where one or both of these guys are infinity. And there are a multitude of different permutations. So I can't really do all of them, but I'll try and do as many as I can. So let's do the integral, our first one. Let's do the integral from 1 to infinity of 1 over x cubed. So I'm picking a really easy one, I think, anyway, to get started. Now, the way that you do these types of questions is that you replace the infinity with the t, and you then make t go to infinity. And the logic says that these are equivalent. In other words, if you get the answer to this, it's the same as the answer to that. So improper integrals are really limits as t tends to some kind of infinity, at least in type 2 questions. Now, if you're going to integrate a 1 over guy, as we are going to do here, I'm going to have to call it a negative power, because those guys use power rules, and you need powers to do that. So this is going to be the limit as t tends to infinity. Add 1 to the power is negative 2. Divide by that power gets you negative a half, and you're going to evaluate it from x equals 1 to t. And then I am going to do this. I call that style points. Why do you think I'm going to use this version rather than that one? What's the advantage? Any ideas?
It's easier to calculate with.
Yeah, that's pretty much it. And isn't it easier to get 1 over 4 squared than trying to figure out what 4 to the power of negative 2 is as an exact value? So typically, that's a good process to do. Now, if you plug in t, you get that. Take away, if you plug in 1, you get that. And so now we are looking at the limit as t tends to infinity of negative 1 over 2 t squared plus a half. A large proportion of these questions like this, a large proportion of them are going to be brute force. In other words, you just replace the t by infinity. So let's see what that looks like. Negative 1 over 2 lots of infinity squared plus a half. Okay, infinity squared is infinite, 2 infinities is infinite. Isn't 1 over infinity 0? In other words, the answer is a half. We will use this phraseology. We will say that it converges to 1/2.
We can't see that text at the bottom of the screen there.
that high enough now? Okay. Well, let's try and prove to you in a pseudo kind of way that that actually works. If you find the integral from 1 to t of 1 over x cubed dx, just that bit, the answer ends up being negative 1 over t squared plus a half, agreed? Right, let's change t to 10. Well, that would be 1 over 200 plus a half, which is, let me check that. Is 0.495. If I did the integral from 1 to 1,000, the answer would be 1 over 2 lots of 1,000 cubed plus a half, and that would be 0.412.
It's 1,000 squared.
To 1,000 squared, right, which is 1,000,000. Which would be that answer. Can you see that as this number gets bigger and bigger and bigger, isn't the area getting really, really close to a half? Now, if you sketched 1 over x cubed, it would look like this. And if you start at 1, we are calculating this area to the end of the universe. And we're saying that it's equal to half. So it is possible, isn't it, to get an infinite integral that is equal to a number, right? An infinite integral, something with infinity, right? And it can still work. So that's me done powers. Next fill I'm going to do is that one. Let's do a square root, cube root, fourth root kind of guy, right? Those kinds of questions. So that one's going to represent any question that has a kind of square root, cube root on the bottom. Now that's going to become the limit as t tends to infinity of the integral from 4 to t. This is going to be converted into x plus 3 to the negative 1/4. Are you happy about that fourth root being a negative 1/4 power? Makes sense? Okay. Now, that's going to be the limit as t tends to infinity. Well, basically, you could do a u-sub on this, but if you use the linear shortcut method, you add 1 to the power, and then you divide by the new power. And now you can evaluate it from x equals 4 to x equals t. Now, typically, if you do the linear shortcut method, because this is x, that's why there's nothing extra, but let's pretend it was 3x plus 3, right? 5x plus 3. If it was 3x, wouldn't you do times a third? If it was 5x, you do times a fifth. So bear in mind, if you're going to do this shortcut, that if that's not x, if that's 2x, 3x, 10x, then you're going to get half, a third, or a tenth. Right. Let's plug in the fellas. It's going to be 16 thirds, t plus 3 the 3/4. Take away 16 thirds, 7 to the power of 3/4. And I'm now going to do, and I probably should have done it earlier, but I'm going to do it now. That's what 3/4 looks like in radical format. Okay, time to brute force. If you plug infinity in here for t, see what you get. Infinity plus 3 is infinite. Infinity cubed is infinite. Isn't the 4th root of infinity infinite? Isn't 16/3 times infinity? Doesn't it end up being infinity? And infinity take away whatever won't change one thing. The answer is still infinity. In other words, the area under this curve is infinitely large. We will use the word diverges. And we don't need to, and we shouldn't really say to infinity, because sometimes it won't be. It'll just be it diverges.
I have a question.
Yes.
Is there ever a case where we would get something like infinity minus infinity?
Yes. And you're in trouble. And we have to show you how to do it. Because infinity minus infinity is a big issue. You can't say 0 because one infinity may be bigger or smaller than the other. And therefore the difference could be anything, including 0, but not necessarily 0. So we have to do, we have to deal with it. And I will show you, but not in this question. You may have already met one that does that, because there is a question I know that I'm going to do that does that. So 1 over x cubes, 1 over cube roots. That's that situation done. How about something that has logs in it? How about the integral from 1 to 4 of 1 over 2x, not 1 to 4, 1 to infinity of 2x, 1 over 2x plus 1. Right, that's going to be the limit as t tends to infinity of this guy. Okay. How are you going to integrate this guy? 1 over 2x plus 1.
We can convert it into a log.
We can. Or you could, that's what I'm going to do. Or you could do a u sub u equals 2x plus 1, and then it becomes a log, right? But if you use the linear shortcut method, it's a natural log of 2x plus 1 times what? Because it's a 2x here, right? When you do the linear shortcut method, you have to take into account the multiple of x's if there are any. So do I get a times 2 or a times a half? What do you get?
A half.
Correct. And that's going to be evaluated at x equals 1 to x equals t. So let's see what we get. We're going to find the limit as t tends to infinity of 1/2 the natural log of 2t plus 1. Take away 1/2 the natural log of 3. Okay, time to brute force it. If you make that infinity, isn't that infinity? Isn't the log of infinity infinity? Isn't a half of infinity infinity? Can you understand, although I verbalized it, that this becomes infinity when t becomes infinitely big? In which case the answer is diverges. So we've done 1 over x cubes, 1 over radicals like cube root. We've now done ones that have logs in them. So far so good. Just going through kind of it's the same kind of question, but different kind of algebraic issues that you need to deal with. Let's do exponentials. That's going to be the limit as t tends to infinity, the integral from 1 to t of this fella. How are you going to deal with integrating e to the negative 4t? Two ways to do it. Can you do a u sub? And if you did, you would use u equals negative 4x, and eventually you get the right answer. Or, as you kind of noticing, I'm pushing the linear shortcut method, which means do exactly what you would have done if it was an x, but take into account it's not. So if you integrate e to the negative 4x, you do get e to the negative 4x. Agreed? Then don't you also got an extra times something? And it comes because it's negative 4. So what fraction do you end up? Times what?
Negative 1/4.
If it was 4x, you'd get times positive 1/4. If it was negative 3x, you get times negative 1/3, right? Sometimes it's plus, sometimes it's negative. Now, if you then move to the next step, it's negative 1/4 e to the negative 4t. Takeaway is add 1/4 e to the negative 4. You may well be able to do that in the way it's written. I'm just going to rewrite it a little bit differently. Are you happy with a negative power being the same thing as its positive equivalent downstairs? I find that a little bit easier to deal with infinities. If I said to you e to the power of negative infinity, you may have a bit of a problem figuring out what it is. But let's see if we can do it with this one. If you make t infinite, let's just figure out what this is equal to on its own. 4 infinities, essentially. Doesn't that become 1 over 4 e to the infinity? That becomes 1 over 4 infinities. That becomes 1 over infinity. What is 1 over infinity? 1 on the top, infinity in the bottom. What number is 1 over infinity?
0.
Yeah. Which means that you, in this particular question, you are going to get that. And so we would say it converges to that number. So everyone so far has been brute force. Vast majority of the questions look like that's what's going to happen. And that's fine. Are we comfortable with how you would deal with e to the something kind of question? Same question, but a little sneaky thing in the tail. And I'll keep the question the same. Only this time it's going to go from negative infinity to 1. Any bets on this one? Do you think it's going to converge or diverge?
Diverge.
I agree. Any, what made you think of that? Oops, negative infinity.
It would end up being 1 over negative infinity, which means, well, 1 is basically infinitely large.
Interesting. Okay. Already know that guy. It's the same question, so it's the same integral. It just has a different setup as far as what type of infinity you've got. And you're right, there is a negative infinity involved. That's going to cause some interesting problems in a few seconds from now. It's -1/4 e to the -4. Take away a negative means you add it. 1/4 e to the -4t. Then I'll put in infinity and we'll see what we get. In this case, I didn't change it. I just left it that weird way. This guy I could probably change. He's not the problem, it's this guy. -4 times negative infinity is actually a doable calculation, isn't it? Plus infinity. So what you have is 1/4 e to the infinity, which is 1/4 infinity, because e to the power of infinity is infinite, and 1/4 of infinity is still infinity, so this one diverges. When you were talking earlier, the person who answered my question, were you thinking along those lines? It's just the way you said it didn't quite work for my brain, but that's just my brain.
Yeah, basically.
Okay, so yeah. What's that phrase that's coming into my head? There's more than one way to skin a cat. Isn't there sometimes more than one way to look at how you're dealing with an infinite question, right? As long as you're doing it mathematically correct and it comes out, then we're good. Right. This next question, I'm not even going to do any of it. I just want to remind you how to integrate 2 to the r, 6 to the r, 10 to the r. What's the antiderivative of this? Well, it's 4 to the r. Anything else? If the r bugs you, think about this guy then. Right. What else is missing? Because there is something missing.
All of that on top of ln to the r.
I asked the other class and they had the same problem. Somewhere or other, you missed the integral of a number to the power of x or r. The antiderivative is this guy, right? So somewhere along the lines, I either didn't tell you or you can't remember differentiating the thing and doing the opposite to integrate. But that's the guy. So you're going to plug infinity in there. Well, do you know 40 infinity is infinity and so on. I think that's question 7. You need to know that. This is a version of question 8. The integral from 0 to infinity of x squared over the square root of 4 plus x cubed dx. That's going to be the limit as t tends to infinity of the integral from 0 to t How do you integrate that ugly fraction? What method will we use?
U sub?
Who is it correct? Who's the U sub going to be?
4 plus x cubed.
Great. Just take it a little bit further then. I don't know one changing pen, keep it red for a while. So differentiate with respect to x, and you get 3x squared. That gives you du is 3x squared dx, and you isolate the dx, and you get the integral of x squared square root of u. Instead of du, you get 1/3 x squared du. That becomes the limit as t tends to infinity of, cancel, 1/3 u to the -1/2 du. Now I did two things in one go there. The x squares get cancelled. That 3 in the bottom is 1/3. Won't that square root in the bottom become a -1/2 power? And the reason I did this is so I can use the power rule. So add 1 to the power, divide by the new power, and you're going to evaluate that. Well, you're not going to evaluate it yet. Jump the gun a little bit. You're then going to turn it into x's. And then you can evaluate it at x equals 0 to x equals t. And at this point, I'll just say ... Any ideas about what might be a better way to write this so that later on it's easier to make it infinite? Just a minor cosmetic change, but what could I write this as?
The square root.
Right, isn't it easier to do the square root of infinity than is infinity to the half? At least in some people's brains, mine's included. Are we good? So let's do one of those, can you get infinity, take away infinity stories? Here's a question where if you tackle it the wrong way, that's exactly what will happen. This is the first question where we have an infinity and a negative infinity. So if you've got two infinities, what you must do in these questions is split it into two separate questions. If you kept it together, you might well get an infinity take away an infinity going on. I'm not sure if this one actually does that, but you could. You're not allowed infinity take away infinity. If you ever see that, you've screwed up somewhere because it's impossible to solve. But I can find these totally independent of each other. So imagine a little invisible wall between them. If I wanted to do this fella on the left, it would be the limit as t tends to negative infinity, the integral from t to 0 of that guy, and plus. And if I wanted to do this one on the right, it would be quite similar looking. Agreed? Now, all sorts of things can happen with this particular combination. So I'm going to return to this in a few minutes. I'll pick one of them to do, and then we'll see what we can do. Based on previous situations, couldn't it end up being that this guy was, say, a half and this guy was 2, right? You could get numbers, they just have different numbers or the same, in which case it converges to 5 halves. That answer could be infinity and that answer could be 2. That could happen, right? One could be infinite, the other could be a number like 2. What happens in that situation then? What's the conclusion?
Infinity.
So that one diverges. Technically, this one converges. This one could be a half and this one could be infinity. And doesn't that give you the same result? And sometimes one of them is plus infinity and the other is negative infinity. So we've split it, because that's what you have to do. And even after splitting it, one of them goes plus infinity and the other goes negative infinity. And if you want to imagine what that would look like, not this particular question, but can you imagine a shape that looked like this? On this side, wouldn't the answer be negative infinity? And on this side here, wouldn't the answer be plus infinity? You see it could happen. So what do you think the answer is when that combination of infinities turns up?
Infinity?
It's one of 3 possibilities. So nope, but keep thinking.
Does not exist.
Good, closer. Instead of saying does not exist, we just say diverges. So if you had to do an integral that has to be split into 2 pieces because there's a plus and minus infinity, if one of these 2 pieces, and I don't care which one, if this one ends up being infinite or this one ends up being infinite, and it doesn't matter whether it's plus or minus, because sometimes you can get negative infinities. If either piece is broken, the whole thing is broken. So if either piece is infinity, means it diverges. Which does mean that we are going to do one of these 2 guys, and we are going to find out what the answer is. And if one of those 2 happens to be 0, it happens to be infinity, then we will stop. I won't even bother doing the other one, because if one of them's infinity, the answer is going to be diverges. So that's why we don't say infinity. That's why we say the word diverges. It's another way of saying it doesn't have a finite number that it's becoming, right? Don't we, for instance, say that that diverges? That's not infinite. Would you agree the area under that curve just bounces somewhere between 0 and 1? But it's not infinite, right? So diverges is a better word than saying, oh, the answer is infinite. Even if in some situations that's exactly what it is. Right, there are 2 guys here. I'll call them number 1 and number 2, and we're going to look at finding the integral. So tell me one of them to do.
It's the limit as t approaches negative infinity.
Okay, we're doing number 1 then. I need a method to find its integral, right? It's antiderivative. It's either an integration by parts or it's a u sub, right? It's definitely not an x sub, right? And it's definitely not partial fractions, right? We know it's not those 2 guys. So it's u sub. I agree. What u sub do you want?
Negative x squared.
Okay. That tells me then that du by dx is negative 2x, which gives me negative 2x dx. So that fella isolated. So it's going to be the limit as t tends to negative infinity. the integral of 8x e to the u times negative 1 over 2x dx. And that becomes the limit as t tends to negative infinity of negative 4 e to the u. So it did turn into quite a nice integral, didn't it? Agreed? Nice integral. So that becomes the limit as t tends to negative infinity of negative 4e to the u, which in turn becomes negative 4e to the negative x squared, which is going to get evaluated at t and at 0. So it's going to be the limit as t tends to negative infinity. Plug in 0, that's e to the 0, that's 1, so you get negative 4. Two negatives make a plus. Right. We're looking at this guy, aren't we? Okay, let's try brute forcing it, see what we get. Negative 4 plus 4e to the negative infinity squared. I'm taking this really slowly. Isn't negative infinity times negative infinity plus infinity? Now, some of you can tell me what this is equal to. Do you know what this would be? If not, I'm about to do the next line anyway, but can you tell looking at it right now what this would be equal to?
0.
It's going to be 0. So if you think of it as this guy, does that help you see 4 over infinity? That gets you 0. So this fella here is negative 4. Are we good? Can I tell you that you do this answer and it ends up being plus 4? And that makes the combined answer 0. Give you a few moments. Let's take attendance right now. So say hi. I'm almost finished. all of these questions are, or ones at least similar looking to them, are in this section. So for the few minutes that we've got left, 7 minutes I think we've got left, I want us to look at how you would integrate. Because once you integrate them, you're probably just going to do, for most of them, it's going to be brute force, right? You're going to plug in infinity or minus infinity for t, and it's either going to work out nice and you get a number, or it's going to zoom off to ridiculously big numbers, in which case you'll say it diverges. What technique will we use for question 10?
U sub?
Great. Anybody want to tell us, you can't use you, because I want to have two people in this, what the U sub that would work would look like? Because it's not an obvious U sub, but it does work.
X to the negative 2.
Nope. Give me a U sub that does work.
-1/x.
Correct. And you just have to trust me. I believe you get that eventually. Okay. In question 12, a U sub won't help you. It's definitely not an integration by parts, but it is somebody that we recognize the minute I do that. Do you recognize that guy? Partial fractions. Do you see that these questions kind of need the techniques that have came before? You're going to look at these and you're going to say, oh, I need to do this, I'll need to do that. And for instance, isn't question 11 a trig identity that you need to use? They just keep changing the letter, but you're going to use 1/2, 1 minus the cosine 2 alpha. By the way, that one diverges. Because if you've got a sine or a cosine, don't you always diverge? Because it just goes up and down. It has no fixed value. What do you think you need to do to 13 then to be able to integrate it?
Factor it so you can do partial fraction.
That's exactly what you need to do. Partial fractions. What do you need to do in 14? Have a technique for integrating 14.
U sub?
Not this time.
Integration by parts.
Correct. Make this F. Make this G. So if you're rusty on any of the techniques that we've been doing, can you see that you're going to end up not being able to start the question because you don't know how to integrate it? You've forgotten what method is going to be used, or you use the wrong method. So try not to compartmentalize your knowledge. Oh, I've done integration by parts, close the door. I'm not going to see that again, right? Move on. That's not the way this works. Last one. What's the method?
U sub, but only because you told me at the beginning of class.
Okay, this is true. U sub. Right, so you can't answer it because I told you that in class. What U sub? Because this is an unusual U sub.
ln of
What?
x.
Yes. And can you trust me? I believe you get 12 over U du. So the process of finding improper integrals involves us turning things into limits as t tends to infinity or t tends to negative infinity, which is fine. But that process involves integration. And integration is power rules, turning radicals into fractional powers, turning 1 over x cubed into x negative 3 to the power rule, knowing some trig identities, hopefully not too many, integration by partial fraction techniques, integration by unusual U subs, and integration by parts. And so half your battle now is, and that just comes with experience, so don't be too concerned if it hasn't clicked yet, but hopefully it will click eventually. That's just experience. If you've done enough integrals, don't you begin to see, oh, I've seen something like that before and it was a U sub. Or I've seen something that looked like that and it ended up being a partial fraction. And eventually you get used to it because you do so many. The problem with the textbook is that they give you a whole load of questions and all of them are U subs. And then a whole load of questions and they're all integration by parts. And you know, each one is kind of in its own little compartment. But have you seen now that all the boxes are open and anything could pop out, right? The next question's a U sub. The next one's just a power rule. The next one's an integration by parts. And then after that, it's a partial fraction. So being able to look at things and identifying shapes, this is how my brain works. See, when I see fractions, and there's only numbers on the top, then I think partial fractions. If I see fractions, I'll show you two different questions that look almost the same. I'll turn them into X's. That top guy he's a partial fraction. Who's the bottom guy?
Partial fraction.
Could be, and it would work. And if you wanted to do a partial fraction, there's nothing wrong with that. But he's also something else.
Could you do L'Hopital's rule?
We're not at that stage yet. That would come later. We're still on integration, if you needed to. I don't think anyone's caught it. I'm about to tell you. It's a U sub. What do you get when you differentiate that? So that ends up being 1 over U du. Do you think that's going to be less work than this? Would this work? For sure. And if it's the only one you see, that's great. I have done that. I have, in the past, seen a question and did this, and then the student says, oh, but I tried a U sub on it, and then I look and I think, I got it, you're right, a U sub would have been so much quicker. But hopefully most of the time, because I've done the wrong road, well, wrong road's wrong, I've taken the longer road, that I don't make that same choice the next time I see it. So if you see somebody in the top, have a quick look. Is this guy's derivative anything like this guy? For instance, wouldn't 4x plus 2 also count as a U sub? You just end up with 2 over U. If you see an integral that looks like this, and an integral that looks like this. And they are very similar looking, but the techniques are quite different. Which one of these is a U sub and which one is integration by parts?
E to the negative x squared is going to be a U sub.
And the U sub would be that. An integration by parts. What was it about this that made you think U subs? What was it in your brain that kind of said, you know, ding, go that road, not the other road?
I don't really want to have to take the antiderivative of something to a power that's squared.
So you kind of, it was a process. I don't think it's going to be integration by parts because I don't want to integrate e to the negative x squared because I know that's not going to end well. And sometimes if there's only two major choices and you throw out one, isn't the one that's left the only one that's usable then? Right. I mean, I'm not sure how to phrase that in a better way, but you know, like Sherlock Holmes, once you've eliminated all the possibilities, whatever left must be the answer, right? So if you eliminate all the other techniques and there's only one left, that has to be the technique. And then you have to say, okay, God in Himmel, this has to be a U sub. Where? And hopefully your brain will focus there. When you do U subs, isn't there two parts to a function, and isn't one of them the derivative of the other piece? Isn't that the kind of shape U subs have? That there's an x squared somewhere and there's a 2x or an x somewhere else, right? They're connected as a U sub and the other piece, its derivative, is there somewhere else. And that is us for today. We have learnt some cool stuff, I hope. And goodbye. I'll see you tomorrow. Unless you have some questions, in which case I'll hang around.
Have a good day.
Thank you.
You are welcome. Megan, you got a question or you just slow in leaving?
I'm just slow leaving, sorry.
Not a problem. Okay, bye-bye.